Hey guys, so in this month's new tutorial, we're going to be covering some refraction. This month's tutorial isn't going to be as complex or long like the other last 3-month project-based ones. A lot of people have asked me about this specific scene, about how I got the refraction and caustics and all that stuff to work. So we're going to make a couple little different examples of refractive objects so I can kind of explain to you guys what to do. And so a lot of people have trouble with caustics and refraction and redshift and say, you know, it doesn't look good or it's not realistic, stuff like that. So the reason is because redshift by default has a lot of these things disabled for speed purposes. Now, if you want them, you can activate these things and it'll make your refractive objects look way, way better. But for speed purposes, they're disabled normally. Now, a lot of these options are scattered all over the place. They're in the materials, they're in the lights, they're in the render settings. So it's a lot of different little knobs to kind of turn on and activate. And a lot of people just aren't aware of these options existing. And so I'm going to kind of go over all these different things so you can get much nicer quality out of your refractive materials. And so here we've just got a basic scene, nothing particularly fancy or exciting. It's just a dome light. So we got this big dome light here. And I've got the camera. I've got our diamonds, so we've got a couple different diamonds that I just kind of laid out. And if we zoom in here, look at it from this angle, the diamonds are basically right a little bit below or touching the plane. And that's important. You want it to be as close as possible to the plane. And actually I might need to adjust this one to get it a little over, because you don't want it to intersect necessarily, because that can cause problems. So as a matter of fact, I'm going to come in here and just make some adjustments. So let's transform this a little. So this red line you see here, that's where my plane is currently at. I want to make this just come up just a little bit so it's slightly above. And same thing with these ones here. Let's hit the T key. Fluids is a different thing, so nested dielectrics, we'll talk about that later in another example. But for this, we actually don't want intersections with our geometry. So just lifting it just a little bit will help get rid of some issues that might come up. I don't want it too high up, but you know, just barely higher than our plane. And again, the reason is that this can cause problems with intersections later on, where the geometry of our plane cuts into the geometry of our glass objects. And or this will actually be a diamond shader, but yeah, so now we've got them just a little bit above our plane. Okay, cool. And so to get started, we're going to actually just drop down a material. Now, if some of you guys aren't aware, we can use the material palette now. So I've been building a couple shaders. I actually have my diamond shader right here, and I'm building up this library. I'll share it when you guys when it's ready. So I'm making metals and liquids and stuff like that, different gems. And what's neat about this is you could save this, and whenever you need a material, you can just drag and drop it in. So I have a generic just redshift material that I use. And so now that this is here, we could just drag and drop it onto everything just so we could see what's going on. And actually I should drop another one down. And we'll make this the ground so it's a little separate. And so if we now switch on over to our material context, we've got two materials here. We've got mat 1 and our original material. And these are set up the way I built these to just be generic. 50% grays, a little bit of roughness, so they're GGX. The settings that I usually start out with. So that's how these are set up. I'm going to just call this our diamond. And we'll call this our ground. And so let's save our scene. If we come over here and open up the Redshift render view, and actually let me make sure, since I just updated, yeah, that it doesn't have IPR active here. So when I click this, it doesn't open and start rendering. It just opens the render view, which I prefer personally. And let's just hit play. And here we go. We've got our render set up. And actually our ground might be a little off, so or I might have to rotate these diamonds around. But I'll do that later. For now, we kind of just want to see where we're at. And so we've got just an HDR and a pretty simple setup. Nothing complicated really going on yet. And so let's make our ground something darker. Let's just make it black. Or close to black, not fully black. And I'll explain why later when we move on to caustics, why you can't use pure black. So this is a nice darker color. Let's add a little bit of roughness to this. We'll just drop down a bump. Map. We'll plug this in. And actually, to get the pattern down, let's plug that in on our surface, just so we could see the shape. And so right now the scale is a little big. Let's increase the complexity a little. Let's distort it. And let's run a ramp through it, just so we can control the sharpness a little bit more. So maybe something like that. Let's add a little bit of noise, and I think that's good. Let's now change the scale. Let's try 50. 100, and 100 I think is good. And so we'll plug this back in over here into our bump, plug our shader back in, and we'll plug this into our bump input. And on our bump map, we're going to need to drop this down. Let's try 0.1, 0.01. And see that it adds a little bit of roughness to everything, which is nice. Let's try 001. And I think this is good. If you come in here, it adds just a little texture to our table or our surface or whatever we're working on. Okay, cool. And let's pop this open. And we are using HDR that is in ACES space. So I'm using Rec 709 ASUS, but you could switch over to sRGB. It's up to you. And there is bloom, but it's not really that visible. We're going to activate the bokeh. So this feature is new in 3.06. And so this lets you control the bokeh now inside of the render view. And you can actually click with the new focus picker up here, this icon. You can click somewhere, and that's where your focus is. Really neat. And you can adjust the scale of your bokeh by using, I think it's the Alt key, and clicking and dragging. And so this circle shows up, and this circle controls the size of the bokeh. So if I click that, you know, everything else is really out of focus. If I make a little circle, it's not as bad. So we're going to do something maybe something like that. So our back diamonds are a little out of focus. And as you guys can see, that's super convenient, right? You know, it makes it way easier to work. And okay, cool. So now we've got a pretty decent little shot going. Let's uncheck our focus picker. Composition's pretty cool. This is a nice little shot. And so if we look down here, our ground has got a little variation in roughness. So now we need to work on the actual diamond shader itself. So let's scoot that over. And actually, there we go. We've got the camera. We'll switch over to camera mode. We could use auto if I'm going to rotate around, but we'll keep it at just camera for now. And let's save our scene again. And actually, for now, we'll disable the bokeh, just because it makes the IPR a little slower to process. And we're going to move on over to our diamond. And so a diamond material, you have to know, like, if you're going to have to Google the refractive IOR for a diamond. So a lot of people don't know what these, you know, the IOR levels or the dispersion levels. And so for realistic gems or refractive objects, you need to look this up. You need to look up this information. And there's actually a website that has a long list of IOR values, and you can look up the dispersion or the ebb value, and that will give you the number you need to type in. So we're going to work our way down from the top first. But if you guys just Google, and actually render view's in the way, let's disable always on top. If you guys just Google IOR values, you're going to get the IOR index refraction list. And if you just type in the material and then the abbe, you'll get like the refractive index.info page. So let's click on both of these. And inside of this list, you're going to just see tons of different materials in here. We're looking for diamonds, so we're in the D section. And here we have the IOR value, which is 2.418. You don't have to be exact, but you know, the closer the better. So 2.418. And our color, you could just turn this off to black and put 0 weight on it, because we're going to activate refraction. So the weight for refraction is going to go to 1. And as you guys can see, it turned into a transparent object here once we activated our refraction weight to 1. Now my default has roughness, so that's why it looks kind of cloudy. So we're going to drop that down to 0. And now you can see right through the object, which is, you know, looks pretty okay. Now right now we're getting these black, pure black sections, and that's due to the bouncing trace depth. And so if you guys are still using 2.6, your limitation on trace depth in Redshift is 16, which is pretty small. Most engines, typically they use at least 20 by default. I believe Octane and FStorm are limited to 32. And so Redshift recently in the 3.0 builds lifted this limitation and they added it to 64. Now 64 is a lot. You know, if you guys were going to do this in CPU engines, it starts adding tons of time. The great thing is that the improvements in deep sampling in Redshift and 3.0 actually don't add a lot of render time when increasing your trace depths that high. It does add to it, obviously, because it's bouncing more rays around, but it's not that bad. And I'll be going over some optimizations and stuff that you guys could work on and that I have never really explained because it confuses people, like cull thresholds and stuff like that. But I'll touch on those subjects later. So nice, we've got now the start of our scene. And so typically the reflection and refraction are linked together, so you can't actually adjust the roughness. In a real world situation, the roughness on the reflection is the same as the refraction roughness, but sometimes it does help to add just a little bit of roughness to the refraction, and it kind of just fogs up the inside a little bit, so it's not too perfect. But we might touch on that later. For now, we're just okay. We've got our base IOR set down. It's refracting now. Our color is white, and we don't want thin walled. So thin walled, if we activate this, it's as if our diamonds only had no interior. So if only the outside was an actual object. And so we don't want that. That works for like 1 polygon thick windows, certain situations where it's a super thin plastic or something. But since these are diamonds, they're supposed to be diamonds, and they have thickness, we're going to keep thin walled off. And now we need to add dispersion. Now, dispersion in Redshift just means the Abbey. So if we come up here and we switch over to the refractive index page, and here we have diamond, carbon diamond, and you guys could, you know, there's other options in here. You guys could check out different glass, different materials and whatnot. We're only selecting diamond, just simple diamond, and you can see here that our refractive index is the same, almost 2.4117 instead of 18. It just rounded it up. And our Abbey here needs to be 55.3. And so that's what dispersion really means in Redshift. And so 0 means it's off, and higher numbers means less. So you can see if at 67 we started getting these color shifts, the chroma shifts inside of our diamonds, and lower numbers actually means more or stronger of an effect. So if we do 6, for example, look, it's just everywhere now, right? And I mean, you might want this for artistic purposes, but we're going to keep this realistic, so we're going to use the number that's provided here, which is 55.3. So let's, 55.3. And that is the physically correct amount of dispersion inside of our diamond. And so just by doing these few things, you could already see that it's starting to look a little better, right? Now, something else that's important in a lot of glasses, we might not really need it for the diamond in particular, but transmittance. And so what this means, a lot of people only think of the subsurface, this as like a scattering for a single scattering plastics and stuff, but actually this is really important for realistic glass. And the reason is because the light typically in fogged up glass or thick glass, colored glasses, the light goes in and it actually starts to attenuate or get absorbed as it passes through the object. And so sometimes adding a little bit of absorption helps. So here's our transmittance color, and this basically, if we switch this over to yellow or some bright color, red, you'll see that what's happening is that as the light comes in, what gets transmitted through the object is whatever color we have selected here, which happens to be red right now. Extinction is different. It's the opposite. And so extinction is, if you look at the color wheel here, here's our red. On the opposite end is this baby blue color, which is what we're getting. And so what extinction, if you want to think of extinction, it's whatever light goes in, everything gets absorbed except for the opposite of that. And so that's what extinction is. And I think transmittance is a little more artist friendly. You just pick the color and it looks how you want it to look. Some people prefer extinction if they're using scientific numbers. This page actually doesn't have anything about the extinction, but so some people prefer that, but we have both options in Redshift, so that's useful. Since we're just going to do this artist friendly, we're going to just use transmission. And so what pure white means in transmittance is that all light goes through. And we're actually going to bring this down just a little bit so that there's a little bit of light absorption. So let's try like 0.98. And this will just attenuate or absorb, hence the attenuation, all the color spectrum or all RGB wavelengths just a little bit, so it's a little bit darker. And I just want that because that adds a little bit of realism where light gets absorbed passing through objects. Even though diamonds technically are very clear usually, they refract light very well, I still just want to add a little bit of imperfection because typically that's one of the things in CG, everything's too perfect. So having just a pinch of imperfection kind of helps boost things up a little bit. So, okay, cool. Now let's move on to a next setting. Now this is another important setting that's obscure that a lot of people don't know about. So that's inside of optimizations. You must, if you're gonna if you want realistic glass, and it's close up like this, it's a still render, it's not going to be behind motion blur and moving and stuff. You want to disable cull dim internal reflections, and this is really important for that. It saves render time to have this activated. That's why it's active by default. So let's actually make a render so you guys can see the difference. So I'm going to come out to our render ROP here, and actually let's switch this over to caustics because we're going to need that later. And underneath our render settings, we're going to just do 256 brute force. And for our sampling, we're going to do, let's just do 264, 003. We want this to be kind of high, so 256. Our refraction, let's do that 512 because most of this is refraction. And our light, let's do 256. And I think we could keep everything else like this. So let's see what we get if we fire off an actual render. And let's save. So here's our result. And actually let's increase our render percent, our fixed scaling just a little bit. Let's do 140, 150, and let's re-render. And right now, the trace depths are really low, only 4, 6, and 6. And I'll show you guys what this means a little later. And so, okay, here's our result, right? Not bad. So let's save a snapshot. And let's come back into our material. And let's disable cull dim internal reflections. And let's re-render. And you guys, it's a subtle difference, but you'll notice it. And we'll give this a second. And notice it took a little longer this time to render also. And so if we zoom in here and we switch between the two, you'll see that. You'll see that what's happening is it's doing what this switch literally says it's doing. It's removing reflections inside of our refracted object that are dim. And so what Redshift does is it detects, okay, this reflection inside this object is kind of dim. Let's just get rid of it and not bother processing more ray reflection bounces. And so while that saves us render time, as you can see, this was 19 seconds, this one was 16. What happens is that it gets rid of these really nice internal reflections right here, like these white, really hot speculars. And so for quality purposes, to make nicer renders, you want to get rid of this. It's important for nice looking glass. So that's one really important feature that a lot of people have no idea about. And so that's under optimizations in your Redshift material. So let's make another snapshot. And let's just save again. Now under advanced, there's more of these options in here that are important. So there's the reflection end color. And so right now it's on diffuse. And so what this means is that once we hit our limit of refraction or reflection depth, so right now it was 4 reflections and 6 refractions. Once you hit that limit, what happens is it just reflects back a flat black diffuse color. So if we zoom in here, you'll see that this is what we're getting here, just pure black. And that actually looks kind of, you know, crappy. It doesn't look that good. So like you can see it really right here. And so with this option here that you could switch to environment, what this does is instead of reflecting the black when we hit the limit of our trace depth, it's going to reflect back a copy of our environment, our HDR that's in the background. So if we render this again, you'll see a difference. And it's subtle. These things are all subtle, but they make differences in the overall finished product of your render. And so eventually you do hit a limit where you can't go any further. But let's see if we can see a difference here. And so it's reflecting our environment, but it's kind of weird. That shouldn't look like that. But I suppose that is what our HDR looks like. Since it's got a lot of black in it, you can see it on the ground. So this is also important. Now, we're hitting our trace depth limit, so that's what's happening. So let me switch this back to diffuse, and I'll show you what happens when we increase our trace depth. And there's also another option down here for refraction called shadow opacity. Now this is important also when working with caustics. You need to have this on if you're going to have caustics. So right now, if I just if we look at this, it doesn't look like there's any real shadows. The light's kind of going through the object. And if we increase this to 1 and render, we should be getting some shadows somewhere. Let's see here. Yeah. So like right here, you'll notice it more. See, this is without shadows on. And so it looks like the light is going through. And this is like a fake caustic. And so normally, if you're not using real caustics, you want to keep this at 0. And it's just kind of a performance thing. It's like, oh, it looks like there's, you know, caustic light kind of going through the object and stuff. But realistically, once you do actually use caustics, you want the shadow to be at 1. For now, we'll keep this at 0 since we're not using caustics yet. We'll activate that next in a little bit. Okay, cool. So what do we need to do next? Is we need actually our HDR to bend through our refractive objects correctly. So if we come up to our objects, all redshift lights have this option, I believe, except for point lights and spotlights. And so this is really important also. And by default, it's not activated because it's meant to save speed. Again, this is a performance thing. And so if you click on your light, there's an option under ray contribution called affected by refraction. And so usually it's on auto mode. And what auto mode does is redshift kind of just detects is the object got complex roughness or anything like that. And if it does, it'll just skip it and not do it for speed purposes. Or if it is a simple object, it'll actually process the full ray bending inside the object. Now, normally I always keep this on if you want nice looking refractive objects. So there's this option down here called always. And so what this does is all your light comes in and actually bends correctly inside your object. So let's re-render our scene here so you guys can see it, the difference. And again, this thing is subtle, this option, but it does make a difference. So you could see not only on the ground, let me see if we could see it somewhere up close. Not so much up close. Okay, you could barely see it here. You see this like changing in hue? You guys might not be able to see it on the screen recording, but it is there. And so this subtle like difference in the way that the light is bending makes a big difference once you start bouncing more light inside of these things. So always activate this. This is another thing that lights should always have activated. We have an extra secondary light, but this is going to be our purely caustic only light, so we don't need that actually activated at all. Now, arguably the most important setting is trace depth. So if this is just default, if we switch over to 64, it's 63, but it's actually 64 because the first bounce is automatic. So if we switch over to 63, 63, 63, this is going to take a little longer to render, but it's going to make a big difference. So I'm going to let this render. And the time to render isn't drastic. It's going to probably add maybe like 20 more seconds or something. But if we zoom in here, you'll notice that black that we had before is basically gone. So if we check out our previous render, you'll notice these big black empty areas, and that's what that is. That's when our trace depth was hit. And so now that we have this, you'll notice way more little light bouncing around in there, and the results are just, they speak for themselves. They're much nicer this way. So if we look at this, you'll notice all these black spots, and now we've got nothing but nice reflections and stuff going on in there. So that's important. So we're going to keep this at 63 for now. And I'll talk about it, actually, the importance of the cutoff thresholds. So this is an optimization that a lot of people don't know about, and it's a little tricky because it depends. It's every scene is going to be different, but how it works is this is a system where Redshift cuts off ray bouncing around and ray tracing, and so by default it's pretty sensitive. It's at 001, which means that it's not going to cut. The thresholds the rays aren't going to be cut off that soon. And so what this means is it detects, kind of like earlier where I showed you guys the cull dim internal reflections. What happens is Redshift detects the diffuse, reflection, refraction, shadow, and direct lighting, and it says, hey, is this that bright, or is it almost invisible? If it's almost invisible, then stop calculating the rays and move on. And so the larger the number here, just like the unified sampler here, the adaptive error, the less high quality it is. Okay, so right now it's pretty high quality. It's pretty sensitive. Notice that direct lighting is a lot higher up though. And the reason is because direct lighting is typically easy to calculate. So this took 1 minute and 8 seconds. Let's add a snapshot here. And just so you guys can see the difference here, diffuse, we're going to make that 0.1, 0.1, 0.1, 0.1. And we're going to re-render. And so by doing that, what I told Redshift was, hey, if you see diffuse rays, reflection rays, refraction rays, shadow, or direct lighting is no longer really that noticeable, skip ray tracing and move on. And so what this does is it increases performance significantly. As you guys can see, this is rendering already way faster. But it comes at the cost of possibly adding a little bit more noise, because it's no longer firing rays and it's just stopping at a certain level where it says it doesn't notice it as much. So let this finish here. And so now it ended in 45 seconds instead of the minute and 16. So let's zoom in here and let's see if you guys can see the difference. Notice how it's very subtle. So like right here, this little area, the dispersion is disappearing. And the reason is because the refraction probably said, you know what, that's so subtle, let's not calculate it. You know, you can see it here. Let's check down here. You can see it, some of these specular light influences down at the bottom. And so really, the this will depend on your individual needs. And so notice how, you know, this shaved off, what is it? 1 minute, 8 seconds. That's a pretty big difference, 45 seconds to 1 minute and 8 seconds. Doesn't seem like a lot, but imagine if this was 5 minutes versus 8 minutes, you know, as complexity increases. So this is one of those little secret optimizations that a lot of people don't understand or know how it works. So if I were to make this, let's just go really high just for absurdity. And re-render this. It's going to render faster, and you'll notice that things are a little noisier now. If we come in here, see this? And so what Redshift decided to do, it said, okay, this specular white color here, it's no longer important. And so it kind of just skipped it. It didn't fire as many samples there. And you could see the same thing going on in here. See, it's cleaner. And so this time it only took 28 seconds. So it's a balancing act, guys. Like, every scene's going to be different. You might need to change it for your own needs. I think for our purposes, the ones we need to focus on is really only reflection and refraction. So if we drop this down to maybe 002, 002, we might be able to get away with shadow and direct lighting this high. So let's see what happens. And you know, this is without even adjusting our unified sampler or any of that stuff. Yeah, and I mean, look at this. It looks almost the same as the one where we had it fully sensitive, but actually our settings are a little higher this time around. And so it might save us a little time. We'll see how it turns out. Not necessarily, though. It might not. Just something to keep in mind. And so, yeah, that's the cutoff thresholds to sum it up. Russian roulette is another thing that deals with when to give up on which rays. This is going too hardcore. I don't think most people should mess with this, because if you don't know what you're doing, you can make your renders get way longer. But okay, look. For example, this is 1 minute flat. And if we compare it to our original 1 minute and 8 second one that had more sensitive settings, it looks pretty much the same. Yeah, I can't. There's a little difference on the ground. But overall, it looks identical. And so this is something to keep in mind, guys, if you want to save render performance. Ask yourself, you know, what is more important in your scene? You know, for our little shot here, shadows aren't that important. Direct lighting's not that important. Diffuse is okay. So the only thing we need to focus our rays on is mostly reflection and refraction. And that's you know, it's good to go. Cool. So let's move on. And actually, we could probably lift this up to 0.5. And okay, so now we've got our diamonds looking a little better. Let's go back to our material. And we're going to switch over to environment now. And let's re-render our shot. And we're going to move on to caustics now. Now, caustics will also depend on your scene. They can be a little tricky. It really boils down to the scale of your scene and the type of light you're using. So normally I tell people, since we don't have ray traced caustics, caustics with your HDR are usually pretty bad. You want to use a light. Now, the best looking caustics will come from a spotlight because it's a infinitely small point, so it focuses your caustics a lot better. Area lights with directionality will also look good, but spotlights generally look better. And let's come in here and see how our environment looks. And it looks fine for pretty much everything. Okay, cool. So let's activate our caustics now. So what we need to do is activate our shadow opacity. Move this up to 1. And we'll adjust this once we have our caustics. But 1 is what kind of where we want it at. And another thing that we need to activate is under global illumination, the conserve reflections energy. You actually want to disable this. What this does is it gives us these little fake kind of caustics, this little glow underneath. And we don't want that because we're going to use real caustics on the ground. So you want to disable this also. And again, this is another one of those performance things that Redshift uses. There are soft, fake caustics where you don't need high quality caustics coming off your objects. So we're going to disable this. And we're going to come up to our objects, and on our diamonds, we need to make sure to activate cast caustic photons. So we're going to activate all this and keep that activated here. And technically, you don't need to be visible to GI, but that's a whole other thing. That depends on the glass. This might not need that setting. So now that we've activated that, we need a light that's actually going to emit caustics. So we've got this light that I parented to our HDR here. So if we look at it, it's right there. It's this area light, and it's pointing at our scene. Now, I'm going to make another one that's going to be a spotlight. So let's actually duplicate this so you guys can see the difference. And we're going to turn this on. Instead of an area light, we're going to switch over to spot. And you can see kind of the influence on the ground here. It's well, it's hard to see, but you can see that there's our spotlight shape. And what we want to do for both of these lights, so let's turn this on also, is since this is only going to emit caustics, we want to disable effect diffuse and effect specular. So that way it doesn't actually light our objects, it only creates caustics. So we're going to do the same thing here for our spotlight. And you could activate affected by refraction. It's not really going to make much of a difference. And here we've adjusted the spread so that our area light isn't spread wide, it's a little closer inside, kind of like our spotlight. And now we're going to switch over to shader. Now the intensity and the color, you can adjust this. This influences how the caustics are going to look. And what's most important though is under photon, we need to activate emit caustic photons. So we're going to keep it just 100,000, which isn't high quality. This should be really quick to render. And we're going to do the same thing here. Emit caustic photons. And we're going to just let it do its thing. And so we're going to disable first our spotlight, so you guys can see what it looks like. And finally, inside of our Redshift ROP, you need to go under global illumination, photon mapping. We could disable enable GI because we're not going to use GI photon mapping. And here's your options for your maximum number of caustics and your search radius. So you could think of your search radius as like your softness, your fuzziness, and your maximum number as the maximum number of caustic points that could be collected. And so I'll show you guys the difference once we start rendering with the render view panel that gives us the information. So in the 3.0 builds, there's this new render info option. So if we click on that, we'll get this. And this gives us information about our scene, the caustic points, etc., etc., etc. And so we're actually going to make a new window so we could keep that open. New floating panel. Bring that down. Right click. Switch over to the Redshift render info. And we'll just keep this open on the side. And let's look through our camera and hit render this time. And keep in mind, caustics only work in bucket mode. So if you guys are doing progressive renders, you're not going to see the caustics. And unfortunately, because caustics are point based, they're not ray traced yet, though they plan on adding ray traced caustics also as an option soon in the 3.0 builds. You'll be able to do this in IPR mode, and it'll work better for HDRs. So if we hit render, and let's actually save just in case, and give this a second, you'll notice all this information starts popping up here, telling us about how much memory is being used, how many caustic points are being generated, etc., etc. And if we actually come up here, it should tell us it only made very few photons, so it only made 33,000. Usually you want to be in the millions for clean caustics. And so we're going to check our caustic AOV, and you'll notice it's pretty much empty. Don't see anything. And so that tells us a couple things. Either our search radius is too weak, or I mean too strong, so it's blurring them out, or our light is not intense enough. So we're going to switch down to 0.1 and re-render. And again, let's check our caustics here. And it doesn't look like we're seeing anything yet. So let's try 0.2 and re-render. And now we're getting something. So it's subtle, but you'll see them right here. Okay, now we're getting caustics in our scene. So when you're first working, make sure to adjust this, and this setting will depend on the scale of your scene. So when you start working with caustics, one of the first things you should do is find out what your search radius for the points you're firing should be. So here we go. We've got some caustics here, and they're noisy, you know, because our settings aren't good, but you could see them in some spots. Cool. And if we actually look at the feedback display, and we come up here, and there should be our caustic settings. Here we go. Now we fired 100,000 caustic points, which is basically the limit of what we told the light to fire. So for our max number to save in here, we're going to just switch this over to 2 million. Now let's just do 20 million. And when you do this, this will increase your caustic memory usage. So there, where is it? The let's scoot this over. The points, the cache point memory will start to increase. So just keep that in mind. When you do start getting more caustics, you do take up more memory. But one of the neat things is once you're happy, you could just write out the caustics to a file, a cache, by switching from rebuild, don't save, to just build pre-pass only, and then you could load, which is neat. It's kind of like the Irradiance point cloud, Irradiance cache. So once you're really happy, you can render out some really nice clean caustics and then just save them. And then you could make adjustments to the rest of your render without worrying about the caustics. So let's go back to our object. And we're going to look at our light. And we're going to increase our number of photons now. We're going to go over to 1 million. So usually you want sometimes up to 8 million or more. And this will give us cleaner results. And another thing you could do is you can increase the intensity of the caustic color, which is cool, without actually having to increase the light intensity. So if I were to make, let's just increase the exposure to like, I don't know, 2. And I render, our caustics should be quite a bit brighter. Yeah, so you can see them right here. They were brighter than before. You can see them down here. And so there's 2 ways to increase the intensity of your caustics. You could increase your light intensity, obviously. And if you just need to adjust it a little bit, you can adjust the intensity multiplier to dim them or increase them just a little bit without adjusting your light, which is pretty useful. Cool. So now we've got some caustics on the ground. And they're a little too strong in my opinion, but you know, we could drop down the intensity, make adjustments, so maybe we'll make that 1. So now let's check out what this looks like using our other light, which is using the spotlight. So let's disable this. Switch over here. Turn this on. And actually, let's leave the shader on. And we'll keep the setting at 0. We'll see how it looks. And we'll emit 1,000,000. And let's just see what happens, you know. Let's save a snapshot. So if you look at before, without caustics, with caustics. And you guys can see that it's what it's actually doing also is it's affecting the interior of our diamond, because the caustics go inside and bounce around. And this is why you want to get rid of the fake caustics on the ground, and you want to add a shadow, because otherwise the caustics get too intense and you're adding extra caustic on the ground, a fake caustic essentially. So let's try now to re-render this. Let's save. And this time we're using our spotlight. Generally, spotlights provide sharper, cleaner caustics because they're infinite point lights. But we'll see how this ends up looking. We might need to make adjustments. And it doesn't even look like any of them are even there. Nope. So let's disable that. And we might need to actually change the location here. But let's see. Let's increase the exposure. Let's just do 5 to make sure that it's getting enough light. And try again. And it's looking like our light is not creating any caustics, which is weird. Let's see here. Total number of photons. Yeah, 990,000. So, oh no, that's a different one. Yep. Yeah, and it looks like it's not making them, which is strange. So let's actually enable this and see how bright our spotlight really is, because it just might not even be bright. And from the looks of things, something is definitely not right. Oh, oops, that's why. I was on the caustics AOV. And actually it doesn't look like our spotlight's bright enough. So if we on off it, yeah, it doesn't even look like it's on. So what we need to do is make it brighter. So here we go. Now we can start to see it on the ground. So we're going to try something like 1,000. And this might be bright enough, might not be. Let's go up even higher. This might be bright enough here. And let's disable that again. We'll keep caustics on, and let's hit play with a bucket render and see what happens. And yeah, it already looks like the caustics are way too strong now. But but now they're working. So yeah, sometimes because area lights are the intensity of the light is dictated by the scale of the light. The area light is bigger, so it's brighter, while spotlights don't have any scale. They're infinite points. So you actually need to adjust their intensity. The same intensity here for an area light and a spotlight isn't going to be the same. So let's actually drop this down now to 5. Or let's do 2 and see what happens. Okay, and we've got caustics now. And they are a little too strong still, but we'll just keep it on for now so we can see the differences. Between an area light and a spotlight. So let's zoom in here, and you'll notice that the spotlight caustics are much sharper. They're very sharp, actually. And so if you need very sharp caustics, spotlights are better. And they clean up faster. So if we compare the area light to the spotlight here, you can notice a big difference. So you can see the RGB banding, and you'll notice here that it's kind of smudged away. There's some caustics here, but the overall detail of the caustics aren't as nice. And so that's why I personally tell people, I recommend to them, use a spotlight. And right now they're a little too sharp. So what you can do is go back to our ROP and the caustic search radius, increase this value a little bit. So let's do 004, and it'll soften the edges a bit. So let's try to re-render again. And now they look a little softer. But they're still there, you know. So if we switch over to our caustic AOV, you can see them. And they're just more detailed. They're sharper. They look a little nicer. So that's the difference between the area light versus the spotlight. And the area light actually caught the outside a little better inside the objects. So maybe we'll use the area light. In this particular scene, it looks like the area light's a little nicer. But generally speaking, the spotlight gives you cleaner, sharper, faster results. But I figured I'd show you guys both options here. And of course, these shapes change based on the color of the object and whatnot, and also the size. So as you guys can see, the penumbra of the shadow and shape is different than, I'm sure, the aerial light, which is coming in this way. So it's almost like if I were to make this bigger, it would make a difference on the cone angle. So rather than shrinking it down or making it larger here. So let's just try, just so you guys can see the difference. We're going to use 130. And let's save a snapshot here. And let's re-render. So you guys can see the difference that just the cone angle made. And so that'll make a difference also on our aerial light, but not the cone angle. It's the spread. So the spread's really tight, as you guys can see there. So let this do its thing. And it's actually kind of subtle. But it did make a subtle difference. But okay, I think for our particular scene, we're going to stick to the area light. I think it looks a little nicer, it catches the bloom a little better. So we're going to disable that. Switch on over to our area light and activate this. And I think we'll increase the intensity just a little bit. Let's do 1.3. Let's head on over to our out. And I think we'll make these a little bit sharper, so we'll use 001. And we'll increase our maximum caustic points, so it's a lot higher. And we can actually write this out. I think I'm going to do that so that we use some nice high quality caustics. So I'm going to go to our light. And we're going to switch over to 8 million. And we're going to build out our cache. So if we come up here, it's going to be our scene. We're going to go into text for texture. And we're just going to call this diamond scene caustics 01. Accept. And we're going to rebuild. You could either rebuild just the pre-pass or just rebuild. We're going to just do the pre-pass. And so if we hit render, it's going to take a little bit. And I'm going to show you guys where this file is. So while this works, let me pause it for a second. And actually, I just realized I forgot to give this a name. Let's just do .rs, which is the usual Redshift format. I forgot to put that in there. And let's just hit render again. This shouldn't take too long. It is generating, let's see here, about, oops, what is it, 7 million points. We could do way more than that, in my opinion, to get cleaner caustics. And I believe it's done. Yep. And so it took about 14 seconds. And so we now have this file called diamond scene caustics 01.rs. And so what's cool is Now we can just click load, and it's going to load this file, so we don't have to calculate our caustics anymore. So if we just hit render, it's just going to go straight to rendering. We're not going to calculate caustics, which can take time. And so they're still a little noisy, but not that bad. Let's switch over to caustics here. Yeah, no, they're pretty clean. And so you guys could see how this could save you time while you're doing look dev. Just make one caustic pass, and that's it, you know. And you could load it back in for your animation or whatever, and you'll just be rendering like this, and you'll have nice high quality caustics for your scene. Cool. So now we've got some caustics on our diamonds. We've got some nice trace depth. I need to adjust the diamonds because they look kind of like they're floating, so I need to rotate them just a little bit to make sure they're on the ground, and work on the texture, since it looks like the texture's kind of bugging out right here. But overall, it's you know, they're coming together. So yeah, I'm gonna pause this and I'm gonna adjust the diamond positions, and then we'll be moving on to probably our next scene after we do a final render with depth of field. So I'll be back, guys. Alright, so I adjusted the positions a little bit and rewrote out our cache using higher settings. So right now my caustic cache is 1.5 gigs, which is pretty big, but now I don't have to deal with rewriting it, so it's worth it, you know, if you're making stills and checking your render settings often. The only thing you got to keep in mind is that if you do move objects around, you have to rebuild this. So once you're kind of happy with the layout and stuff, that's when you might want to do this. Cool. One last setting that I forgot to mention actually was up here, the sample filtering. There's the max subsample intensities. For refractive glass objects, it's usually a good idea to increase this so that your specular intensities can get high to higher values. So you could try like 20, 20, 20 or higher. Maybe after a certain point it doesn't really make as much of a difference, but 10 to 20 is usually a nice number. And if now we render this out, and let's actually increase our sample settings now, since I think we'll go for the final with depth of field. So let's do 512, 1024, do 512 on the light. I think our GI with the brute force, we'll just do 512 also. And we'll get rid of our caustics AOV. We already know we have caustics in our scene. Actually, I'll leave it in here for you guys if we need to see the caustics. And there it is. And yeah, I think we might just have to go raw unified sampler because of the depth of field, but let's see. Let's just do 2048 because we're gonna have a pretty heavy depth of field in our shot here. So let's activate our bokeh. Let's save our scene, and yeah, let's render and see how this ends up. And so it's gonna automatically just start rendering because we're not generating our caustic pass anymore, which is great. And yeah, I'm gonna pause this so you guys don't have to sit around waiting, and I think we'll move on to our next quick little project. And actually our bokeh looks ridiculously strong, so let's pause this. Let's hit render here and change our focus location. So let's focus here. Maybe this big. A little bigger. And what is going on here? It's not selecting my focus distance correctly. It's at 100 for some weird reason. So something is bugging out here. Let's switch to auto. Disable it, enable it. Huh. Yeah, it looks like it's not updating when I click. I'm going to disable it, enable it, click there. Yeah, it's strange. Okay, well, I'm going to have to manually adjust this then because it looks like the point click depth of field is bugging out. But yeah, so I'm going to make a final render here with some bokeh and we'll see what the result looks like. So I'll be back. And actually, real quickly, it looks like I narrowed down where the source of the bug is. It's so you can see that it's updating pretty quickly when I click around now. And earlier when I had it on load, as soon as it starts loading the caustics, if I click, now it's taking way longer. And it like locks up. And you can see it trying to update down here. So I'm going to have to report that. But so if we switch over to rebuild don't save, now it's much faster. So I'm going to adjust this. And actually let's click here. And I think this is good enough. And so we'll do our final render here. Alright guys, so I'll be back. Alright guys, so here's our finished result. I made a couple adjustments in the post effects, but nothing crazy. And we've got some nice bokeh going on, got our caustics, and overall, you know, pretty good result here. And the total render time was a little under 5 minutes on 3 GPUs. And if we compare it to what we started with, so this is our initial starting render, and I did move the floor a little so you can see that. But just looking at the diamonds themselves, making all those adjustments make a huge difference. So you could see just the detail inside of the shapes and stuff are just much nicer than how we had them originally. And so that little bit of detail in the caustics and everywhere else just goes a long way. And obviously nice depth of field, the bokeh and all that adds an extra finishing touch to the overall presentation. So cool. I think this is good enough. I might maybe just make a quick little animation of the camera rotating just for fun. And I think next step we'll be moving on to doing another scene with a slightly different example, and we'll be using pretty much the same techniques except our IOR values are going to be a little different and stuff. And yeah, so cool. Let's wrap this scene up. I'm going to save this out as an EXR, and I think I'll make a little camera move just for fun. So I'll be back guys, and we'll be moving on to our new scene, exploring a different material. And so here's our resulting render, and I just loaded up the EXR file sequence inside of mplay. And so let's just hit play, and we've got, you know, some cool refraction, the dispersion, hue shifting inside of there, a little bit of movement with the camera and whatnot, and so pretty cool. we came out with a pretty decent result. And you know, we could play this backwards and see how it looks also. The bokeh looks cool back here, out of focus, and the caustics are on the ground, and so not bad for, you know, I think an hour of work here, and it rendered pretty quickly too. So anyways, we're going to move on to our next scene. We're going to just copy and paste some of these, some of the camera and stuff that we already have, our ground, you know, instead of remaking everything. And we're going to move on to making a liquid cube so we can talk about transmission and some more caustics, and also nested dielectrics and how that all plays a role together when you're dealing with liquids and layered refractive objects. So let's move on.